hopefully everything's all set up. Let's see here. I should probably switch this just to make sure you can all hear me. Good. All right. Let's see here. Let's check to see whether things are going the way I think they're going. Just to see. All right. That is what I'm expecting. Good. And I'm checking as to whether streaming is working correctly in all the places where I'm sort of expecting it to. Indeed, it appears that I am actually live on YouTube. All right then. And yay, it works. All right. So last time I was struggling with a problem here. Here I'm going to go and show you what I did in order to solve this problem. Because I did solve it, and it was a stupid problem, and it was my fault. Like all such problems are. Like when computers, well, no. I was originally suspecting that it was a bug in catch 2, but I was wrong. It was a bug in my code. So let's check to find out where this bug actually was. So we go into CMake build debug, right? And go in here, and one of the things that I discovered about this is that one, I didn't actually have to do this by hand. Here's how I discovered that. So let's make a change to this file, right? Because this is the one where I care about it. That should force a change. So, and it's using Ninja. You can tell because it says build.ninja, and that's the default for CMake on JetBrains, I think. So we'll do ninja-v. And here we go. And then we can see, oh, when it does the C++ compilation, it uses -E here, along with all the other flags that it's passing. And then it outputs that to a .i file. So indeed, it actually runs the preprocessor as a separate step from the actual compilation, which is a very interesting thing to know. Yeah, it's a very interesting thing to know. So let's see here. So, given the fact that this is the case, that means we can just look at this file, right? And we can look for what's going on here. And so we can see that it's there. So let's look in here. And we can see this. And let's look to see if we can find check iter equals check end. And there we see that. And basically looking through this, it was kind of impenetrable. Like catch 2 does some very interesting and bizarre things. But what this did enable me to do is it enabled me to understand more of what I was looking at to find. Okay, what I did after this is, because this was so impenetrable and it was kind of a difficult thing to figure out, I instead decided to do something else. I put in an infinite loop. And I made the infinite loop. I did this. I said, I did this, and I said, or volatile bool g, just g equals false, right? And it was important that it be volatile, and then I put in here something that says and actually what I did is I made it true is what I did, because I didn't have not G, I had G. Okay, so one thing about that code, this is volatile, right? It's got to actually read the value in this thing. And it doesn't matter whether I put a breakpoint here now. Now I can run this scenario, and I will build it again. Oh, actually, I have to do it in 2 steps. I want to declare it extern just because. And then I can say volatile bool g equals true, like that. Declare it extern and also declare it volatile. There we go. Now build is finished. And then I can just debug this. For some reason or other, it didn't notice that there's scenarios here and all of that stuff. Doesn't really matter. It's spinning. Like, it's doing all this stuff, and it's going and when, then, and all of this, and it's like, but now it's spinning. I can just hit the pause button. And I can tell it's stopped right there. Now, when I did this the first time, it didn't conveniently stop right there. What it did is it stopped in a bunch of inline assembly, and I had to step out of the assembly, and yeah, it showed me the assembly version of it because it couldn't identify what line number it was on. And so then I had to step out of the assembly, and yeah. But that enabled me to have a place where I knew it would have to continue. Like, the rules of the language insisted that if it got to that line, it would halt forever. Because it has to assume that this volatile basically says G can change at any time, which is a very dangerous thing because people think it means things that it doesn't mean. It doesn't mean that some other thread can change it and then this thread will see it. Like, that's not what it means. What it's usually used for is it's used for things like a signal handler that is executed by the same thread might change it, for example. Or this is actually memory is mapped to some variable that get changed by the operating system, or it's mapped to, like, we're in a embedded device context, and this is actually a piece of memory that is a device register. It might mean any of those things, but it does not mean that some other thread might be able to modify it. Some other thread might modify it, and you might even see that modification, or you might not. Because just because another thread modifies a variable doesn't mean that thread, just because thread A modifies a variable doesn't mean that thread B will ever see that modification. Because thread B might be running on a core that only shares like an L3 cache, and the modification of the variable in thread A might only ever get sent out to the L1 cache, and who knows when it will make it out all the way to the L3 cache or all the way to memory. You never know. It might never. So that's why you can't ever rely on it being like one thread updates it and then the other thread sees it. And so people make all kinds of assumptions about what volatile means, and then because it works in some circumstance, they assume it'll work in all circumstances, and it's really obnoxious. And I really don't like the way most people program. Usually, most people just like frob something until it works, and then they don't bother to understand why it worked or what they did. They just keep on fiddling with it until it works, and then once it works, it's like, it worked, I'm done, and they often did something wrong. It's one of the reasons I really hate the idea of vibe coding, because that just turns that up to 11. Just because an AI wrote it for you and it worked doesn't mean it's any more likely to be the right thing than it would be if you did it. Anyway, that is what I originally did to figure out what exactly was going wrong. Because I could then breakpoint it. And then I kind of realized that these things didn't have the values that they were supposed to have. They were both pointing one was pointing at the beginning, and that was impossible. Like the way this while loop is structured, it's impossible that this thing was pointing at the beginning, which means that this then was like the iterator. This code was being executed again for the next then clause, and so that meant that basically the problem was that I had something like that, and I shouldn't. The then should have been part of the inside the when and when. So That was the problem. And because the then was outside, it was actually treating it as a separate case. And add iter is initialized up here, and this initialization code is run fresh for every case. This is basically a test fixture right here. That's why it says given, because that's what test fixtures are about, is setting up the environment that your test is running in. So it was setting up the environment that the test was running in. Again, for this then clause, that it was kind of treating as another when clause. Anyway, so once I moved the then up to here, this all started working. I still actually have a problem, and I don't know why the problem is happening. Let me try something here. So let's do require out1.empty. Require, yes, there we go, out2.empty. Let's debug this. Okay. So we're going through this payload thing, and this adapter should be adapting over this iString stream should be reading payload. Then this should be an adapter from the beginning to the end, and then this should be another. No, that can't be what's happening. So this, it's unclear why this is happening. Like if you actually look at this, it's very clear that out1 and payload, like payload is the second one. So payload is much bigger than out1. I know what it is. I know what's going on. And this points to a flaw in my basically these are two input iterators iterating over the same stream, and I need two string streams. And SS2 that are iterating over the same thing. And now this will work. There we go. Okay. It's because this is a stream, right? And so you have an iterator over the stream that advances the stream. And so this iterator was wrapping around something that was advancing the stream, and this iterator is going through something that was advancing the stream, and you wasn't getting the same thing at all. One of the things that would have made this test more obvious, and I am going to fix this actually. We are going to go through here, and we're going to go this, and then what we're going to do here like this. And then we're going to say that is what we're going to do. Now, when I put the bug back in by having this iterate again over SS1 instead of SS2, now we'll be able to see here. It's not like a bunch of, like, this is 1, 2, 3, 4, 5, 6, 7, 8, blah, 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 right? This is all sequential, and this is like, oh, no, we're getting not sequential at all. Like, this is doing something very strange. That's, as I said, not at all sequential. And so, like, what is going on here? And that's, yeah, excellent question. So that would have highlighted what the problem was immediately, because it would have been clear that whatever the out1 was, it wasn't getting the sequential result things from payload. And that would have pointed at, oh, something is going wrong with the iterators. And yeah, that would have really helped with figuring out why things were going wrong once we saw this error down here. As it was kind of a mystery. Anyway, and I'll just put a comment. Like that. There we go. All right. Now that we've solved this in all of our test cases, run. In fact, I should just run this and see what happens. Like, okay. Before, I'm a little confused as to what was going on here, because before I had also to CLion as a new release. Don't know that it's relevant. Before I was able to get something here with beside the scenario allowing me to go, I want to run this scenario. And now it's not doing that, and I don't know why. Oh, it's because I'm actually explicitly have the scenario as the thing that gets run. So actually I have to run all tests. That's what I have to run. There we go. There, all tests. 25 assertions in 9 test cases. And they all ran. Yay! It's nice that it prints out the seed. I'm not using any kind of random generation in the test, but then that makes the seed is basically so that if you do have a random component to your test, that it's repeatable. And here it's saying, oh, you indented this, and so it's kind of a, yeah. Okay. Anyway, I just wanted to take you through my diagnostic journey here. Do I need thread? I don't need thread anymore. That is over. And in fact, it tells me I don't need thread anymore. So we're going to commit. Fix simultaneous. What is those called? There. Okay. Now, there's one last change I would like to make here. So we don't need this anymore. I don't really care about catch string ref. I don't care about catch assertion handler. Don't care about catch internal source line info. All of that was part of debugging the other problem. So the other change that I want to make here is in testing to see if trying to make this ring buffer thing work for things that are not plain old data. Because right now it has a bunch of assumptions about things that are plain old data. I don't know. Is that what I want to do next? I'd have to add reference type. Making difference type work. Well, one difference type is currently irrelevant. I would have to implement an operator minus that allowed iterators to be subtracted from each other. Let's try, we don't want ring buffer test as the thing. We're going to open up go for this file here, right? And then we'll ask Claude about it. Hey. Is there a tool here to ask Claude about something? Local history, bookmarks. No. There we go. Will So basically it says all I have to do is add an operator minus. And that the other approach, caching, So what it says basically is I need to implement operator minus, and that I should do it as this, which that makes sense. And so that is what I shall do. One of the things is if I'm going to change iterator eventually to work with types that are movable, so you can use this thing when you have an input iterator that returns really complex things that you don't actually want to make copies of, that you can only move for whatever reason. Because this is intended to be a generic adapter that turns any input iterator, which is an iterator where you can't go back to the past, into a forward iterator that should be able to work for any movable type. Yeah, in order to do that, I would have to explicitly make it a constant iterator. I'd have to make it a constant iterator, which I'm not quite sure what I have to do to tag it to make sure that it's a constant iterator, because basically this, it makes absolutely no sense for this adapter to allow you to modify the contents of the thing you're iterating over, because this is a cache of the value of an input iterator. Input iterators don't represent any kind of persistent data that you can modify, so the best you can do is make a const iterator that pretends to be a forward iterator but caches things. Making it into a non-const forward iterator would be another form of false advertising, saying, oh, well, this was a data structure, this is a data structure that you can modify. And it's like, no, you can't modify it. This is not a data structure you can modify. So it would have to be a const iterator. And then this would have to return a value type const reference, which would mean that you couldn't go move out of it using star. Which is also right, because the person who is using the iterator shouldn't be able to move out the thing that the iterator is iterating over, because that would imply a modification of the thing that the iterator was referring to, was pointing at. And so it would have to be a const reference that this returned, which would mean I'd have to define reference type. And then the other thing that I would do here would be then I'd have to implement dash greater than, because you still might want to do something with the thing that you're pointing at, but again it would have to be a dash greater than that was const, that would return a const pointer. So there's that. Yeah, that's what I would have to do in order to make this work. And then there'd be a bunch of underlying changes in some of this stuff, so that I would be I wouldn't actually have an array of value types, which imply that the value types have to be default initializable. I would have to have an array of memory that was aligned to the value type alignment, whatever that happened to be, that was big enough to hold buff size value types, however big they happened to be. And then I would have to keep track of how many of them had been initialized. And then as things were evicted from the ring buffer, I would have to destroy them. Or move. Actually, I wouldn't have to destroy them. What I would have to do is I would have to move things in on top of them. Except when it was a new thing, a thing that hadn't been initialized yet, I'd just have to basically initialize and place it. Like I'd have to initialize in place with the thing I got from the iterator, and so it would complicate this logic a whole lot. And I don't really want to go through all of that right now. One day I will, because I would like this to be a very generic thing that could map any forward iterator over anything into a range, into an input, or map any input iterator over anything into a forward iterator that kept a cache. And so, yeah, I would. That would be a future thing. But for now, what I really want is I just want to make difference type faster. So this difference type operator, parent not equal to b, I could do that. Actually, what I'm going to do instead of throwing this is actually undefined behavior. So I don't really want to throw a standard. So I'm just going to do standard unreachable. There we go. And Claude is like all set to agree with me that unreachable is a great choice in this situation. I don't know that it's a great choice, but it is a choice that amuses me because the standard unreachable is explicitly undefined behavior. Like if you ever actually execute this function call, who knows what happens? Anything could happen. And so, yes. And just to drive that point home, I will look up standard unreachable on CPP reference. Invokes undefined behavior at a given point. Basically, this is that's exactly what I'm saying. This is undefined behavior. Otherwise, we can just say, turn 0. One thing I could do is I could go, if they're both equal to the end sentinel, then return 0. But I don't think I want to put in that condition in this particular case. Yeah. That's what I'm going to do for difference type here. And I've made difference type be standard pointer diff t, and that should be good enough for what I'm doing here. And size type is uint64. Actually, I made difference type. Oh, this is not what I want. Yep, this is what I want. And int64t, that is exactly what I want. And I also do something where I go, if it ever goes, if it's ever too big, if combined pos ever gets too large in next character, it also throws an exception. Overflow, too many input characters. Basically, if it can't be represented by the maximum difference type, which I happen to know will be the, yep. So that'll work. Um, let's see if all of our tests work. And indeed, all the tests still work. Ha. It's interesting that all the scenarios pop up here, but they no longer pop up here like they were before when I ran Clang. I'm wondering what was going on. No, not Clang, Sea Lion. Wondering what's going on in Sea Lion's head that got changed. But that's another thing. That should also make the Lexer run faster. One of the things I happen to know from having peered inside the internals of CTRE is CTRE in fact tries to get differences a fair amount, and the way you do difference for two forward iterators normally is you go, you just take one and go I++ until you get to the other. When you get to now you're done, and you basically do like that. You can do like like this. You basically have something that looks like that, and right, and then that the diff tells you what the difference is. That is a way of computing differences when you have only forward iterators, but it's ugly. And apparently, I'm hoping that if it actually has just a subtract, that it will use the subtract instead. I don't know that I'm actually going to go verify that, at least not on stream. I might get a bug up my butt at some point in time and actually go look, but that should be enough, hopefully. And actually, let's see. Let's see if CPP reference agrees with Claude. There's set difference, there's distance. Distance, there we go. That's the one I'm looking for. And so it's going to grab the difference type, and then yeah, see, this is how distance exists if there's no what? There's a so it's using tag dispatch here, but it doesn't have to use tag dispatch. I'm actually very curious now as to how standard differences is implemented in let's try this in Compiler Explorer just to see what goes on here. So we have this code here, and there's no assembly, and no, like, this is, like, there we go. The compilation won't fail now. Okay. So we first declare there's some other problems here too, whereas a lot of this stuff is dependent upon the template when it doesn't need to be, and I don't like that. Well, yeah, we'll just not worry about that right now. I might go through and try and make this super efficient at some point in time in its implementation. What do I call this thing again? I call it and that's the wrong way to include, showing my age. And then oh, not iterator, yes, adapter. And it's adapter, not adaptor. No, it's adaptor. Oh, no, it's adapter. Yeah, that's oh, there. There, much better. And this code for Fred is far more complex than it needs to. Oh, this is the code for Fred. So it doesn't do any. Okay. I should, for example, did I make operator minus work for operator equal, operator minus? Just want to double check. Yep, I made it work for const. It checks. So indeed, it looks like in this particular case, it in fact implements it by doing a subtraction, although move, like checking for overflow error, it's just doing moves. Like, what is it? Where does it actually do any distance a comma b? Like, I don't see it doing any actual subtraction here. What is this distance thing doing? It looks like it's just straight up like throwing an overflow error. Like, no ifs, ands, or buts. Calls overflow error. Well, that's just weird. And what happens if I try to do, like, cut this part out? Oh. But it's not an output iterator. How does it decide that it's an output iterator? Well then. So if I put this in, it does something weird that doesn't make any sense. Suppose I put in return 50 here. Again, it just calls overflow error, like no ifs, ands, or buts. Overflow error. Huh. Let's try something that's easy to search for. 50561. Doesn't show up anywhere. How about nope, still doesn't show up. So that constant doesn't show up anywhere, and it just calls overflow error. Let's look at this. What's it say here? Okay. So how do I get a first of all, it looks like I need to use a tag to get. I need to tag this with a forward iterator tag. First, I need to define a difference type in here. Yep. And in fact, I should say we'll continue doing it this way for now. Okay. So, what happens if I put this in Compiler Explorer? I'm betting if I do this, nope, still weird behavior. What happens if I do that? Probably still doesn't work, because I would need to do this. No. Okay. Let's go. Ask Claude. Okay, I'm actually doing that right here. Reference type, value type, const, pointer. Do I need a size type? I don't need a size type in here. technically I should make this a reference instead, which I will do just because. This solution is a terrible idea. In this particular case, it is perfectly acceptable. And to do it that's the correct way to do it in this particular case. I have minus. This is great. That's also great. Yes, and that's also great. So yeah, that's okay. I'm doing all the things I'm supposed to do here. And it's still doing weird things here. I'm just going to leave the if and if in here. Huh. Well, this is just bizarre behavior. I don't understand why it's doing this at all. Let's see what happens if I try and get it to use Clang x86 trunk. Right. Yeah, this one. What happens if I try and get to use this one? Oh, it doesn't like pragma once here, which that's perfectly valid. There is to us standard and reachable. What are you talking about? There. With enough casts, everything works. All right. So, what does Fred here do? Right, so let's look through here for Fred. There's Fred. It just jumps to something. What is my guess as to what it jumps to? Okay, so it jumps to a specialization of standard distance, which is the very next thing. And that specialization of standard distance does what? It basically just advances the iterator until it sees it. So it doesn't notice that distance type exists. It doesn't notice that operator minus exists. Oh my. So I'm going to have to write my own specialization in order to make this work for any of the compilers. Well, that's disappointing. It's got to be a clean x86-64 trunk, right? There's got to be that. There we go. That's the one that I actually wanted. And again, oh, the obnoxious specialization. All right. So what did Claude here recommend that I do with regards to that bizarre specialization? Yeah. This. Safe distance. I don't care about this. That is what I need to write in order to make distance do the thing that it should for my iterator. How annoying. Like this, right? And this wouldn't be that. This would be right? Then I would have to do that. All right. What happens when I cut and paste this in over here into the Brave window to see what happens? Of course, it will complain about, oh, it didn't complain about the pragma once this time. Well, there. All right. It's still, even though I have a specialization for standard distance with my specific type, oh, actually, I should have specialized it like this. Still. Standard distance. How obnoxious. What happens if I use GCC? Right? Well, there at least. What's it doing here? Doing a comparison. Comparison against -1 against -1 against -1. What is that? This is... Ha! Sirens. All right. So I provide a specialization for it for this exact case. And it doesn't use it. Even though I appear to be calling it right there with sample t equal to, like if you look at the definition of Fred, very clearly yeah, 13 characterites, ice stream iterator, all of that stuff. There's an I, which is that ice stream iterator thing, and a uint 8, 13, which is that. And so what's going on here? Why won't it match this one? What is it? What the heck? Right? A very clear over... just to return 5. And I'm calling this distance that I just declared up here, and it isn't matching it. What on earth? What on earth is going on here? This is so bizarre. And if I get rid of it, I get this implementation of Fred, which again is very clearly, oh, this is an alternate implementation of Fred down here, this one that just throws, right? And then it has a different implementation of Fred above. This is also Fred. I don't know how it decides which one to run, but in this case, in one case it runs this one, and in the other case it runs that one that just throws an exception. This is the implementation of distance should, in fact, try to use the operator minus if it exists. Like, what happens here if I change Fred to just return right? See, then it does exactly the thing that it should do. Is it just does this subtraction, right? And you get essentially a random answer if they don't point at the same thing, which is fine. And that's what it should do. But it doesn't. That's what Fred should collapse to, always. But it doesn't. Standard distance doesn't do the thing that you want it to do. It won't call the appropriate difference type. Should, no matter the iterator category, it doesn't matter if it's a random access iterator or not, it should use the operator minus if it doesn't exist. Anyway, this seems like a question for Stack Overflow. There's another forum I could ask too. I don't like Stack Overflow anymore. 10 years ago, Stack Overflow was great. Well, not maybe 10 years ago. Maybe 10 years ago it was still great. I don't know. But 13 years ago, Stack Overflow was great. And 14 years ago it was great. Probably even 15 years ago it was great. Well, yeah, basically Stack Overflow was great until it stopped being great. And so it stopped being great sometime between 2014 and 2018. Somewhere in there, Stack Overflow stopped being great. And I don't know when. But it started being a terrible place at that point. And it's gotten slowly worse over time. Basically, it's become administered by stuffy bureaucrats who don't, in fact, care at all about whether the answers are helpful. All they care about is whether the answers conform to a certain set of rules, and the people who are asking questions conform to a certain set of rules. They don't care whether they're asking good questions or bad questions or anything like that, as long as the questions conform to a certain set of rules. And as soon as they don't conform to that certain set of rules, well, those questions are gone. Anyway, I'm going to leave my operator minus in here, and the pointer dereference and all of that other stuff. I'm going to eliminate this specialization because I think that this is bad information. I am going to go ask about this problem that I tried to solve. So what is the problem? I'm going to describe the problem succinctly here for anybody who happens to go and look at this later. Nobody's watching right now, but maybe somebody will watch it later. Who knows? So what is the problem? The problem is that it's actually a fairly reasonable thing for a forward iterator, which this is. This is not going to ever be a bidirectional iterator. It could be. It shouldn't be a bidirectional iterator. And it certainly shouldn't be a random access iterator. That's all wrong, because it isn't random access. When you're going over an input iterator, I mean, technically, I suppose I could just, No, I can't. No, it'd just be all wrong. This is a temporary cache of an input iterator. So that a forward iterator that isn't too far behind can still, you can still make a copy of it. In fact, you can make one that's a copy of it that's really far behind, as long as you don't access it until you advance it to the point where it's not too far behind. And so as long as it's not too far behind where the input iterator has gotten to in the virtual input stream, because an input iterator basically reads a stream of characters that's presumed to somehow exist, but the input iterator might just be generating the characters on the fly. It might not be there might not be any pre-existing stream of characters at all. It might just be creating random numbers. Who knows? It certainly can't predict what the character that's 50 characters ahead is going to be. It actually has to read each and every single character until it gets up to or whatever it is that it's reading, the input iterator, whatever it is. But let's pretend it's iterating over characters. So it has to read each and every single character until it gets to 50 characters ahead, and then it stops. Right? That's how you get the character that's 50 characters ahead of your current characters. You have to read each and every single character in between. And a forward iterator is like an iterator where you can you have an iterator that's here, and then you just make another copy of it, and then you can take this iterator, and this iterator still stays back here. So then, you read the 50 characters ahead, and then you can read the 50 characters again. But you can never go back, right? Technically, I could make it a bidirectional iterator, because you can go back, and then going forward is, because bidirectional iterators, you can't just jump around randomly, but you can go backward and forward. I could technically make this a bidirectional iterator, but it's also kind of false advertising, because you can't go back arbitrarily. In forward iterator, it's already a little weird that if the most forward of the forward iterator advances too far, you can no longer access the value and still have it work. You get a buffer overflow error, right? If you try to access the value when it's moved too far ahead, and too far ahead is defined by this, right? So an input iterator, you read the stream of characters. This input iterator, there's one of them, and even if you make a copy, it doesn't matter how many copies you make. When you read this character, it's gone, and as soon as you do ++, the character that you read, poof, gone. No, even if you have a copy of the input iterator, effectively all the input iterators over the same thing advance at the same time. Which is the reason why I had that one problem with the one test, is because I was in fact having one thing and two input iterators iterating over it, and I was getting weird results. I needed two things with two input iterators to iterate over it. And so input iterators, there's only ever one spot that all the input iterators for a given kind of thing that you're iterating over, they all point to the same place. And best way to think of it is like you're just iterating over a stream of random numbers or whatever, a stream of random stuff. And so you can't ever get back into the stream. Because the input iterators, there's no place where anything's ever being saved. It's just, what's the next random number? What's the next random number, right? And so you can't go back. So I needed a iterator where I could go back, sort of. And so forward iterators have a different model. Forward iterators, you start with an iterator. Maybe you make a copy of it. Maybe you make several copies. But when you advance this one, this old copy stays back. Now, if all the forward iterators have advanced to a certain point, then there's no way to get back here. This is gone, right? You can't go back. No forward iterator can go back, but a forward iterator can save the position, and then another forward iterator can move. That's iterating over the same thing, can move forward, and then this one can move forward, and it'll see the same sequence of characters that this one did. So this is the thing that I implemented, is essentially a cache that enables this old forward iterator to continue to work for a certain period of time. As soon as the number of cached values gets out of range, then it stops working. So yes, the input iterator, forward iterator, blah blah blah. But there is no way that I'm going to be able to turn this an input iterator. There's no way you can ever turn an input iterator into a random access iterator. The whole idea of a random access iterator is there is some kind of array of things that can be indexed by number, right? You can get to the 0th thing, you can get to the 50th thing, you can get to the 512th thing if there's 512 of them in total. You have a certain number of things, and you can get to any one of them. You know a priori how many things you got, and so you can just get to blah. And getting to any one of them is a constant time operation. Like there's no like blah 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 going forward one by one by one. No, you just go. I want here. Oh, I want there. It doesn't promise that there's any kind of memory layout issue. Like it doesn't say, oh, all these things are laid out contiguously in memory or anything. It just says that it's constant time to get to any given one of them, no matter where it is. And so that's all a random access iterator promises you. And so the idea, anything that a random access iterator is iterating over, you kind of have to have some idea of how big it is to start with. Although technically you could have a random access iterator that iterated over a fixed range of integers. Like I want the integers from 0 to infinity, but only the ones that are divisible by 3. So, like 0, 3, 6, blah, blah, blah. And so then you can easily, like at any given point in time, constant time operation, compute any position just by multiplying some number by 3. You get to that position, right? But you don't actually have to have anything stored anywhere. It's still a random access iterator because you can get to anywhere in it, and there's a clear notion of what's one forward and a clear notion of what's one back, but there's no actual data that's stored anywhere. And that's still a random access iterator. A contiguous iterator, there is stuff that's stored. It's in memory. It's in one spot after the other spot in memory. Like they're all contiguous. That's the highest category of iterator that exists. But the difference type, the difference operation, or the distance operation, looks to find out, is this a random access iterator? If it is, computing the distance is very easy. I can just subtract them. But if it's not a random access iterator, then I can't do that. And that's not the right notion. Like, it's perfectly reasonable for a forward iterator to know how far forward it is, right? And to know, okay, I had this iterator and I had that iterator. If I subtract them, that's how far forward I am. It's perfectly reasonable for it to know that. It's also perfectly reasonable for a forward iterator to have absolutely no idea how forward it is. Like, there's no requirement, and there shouldn't be, for a forward iterator to keep like a count of how many characters have been read or whatever. But it's also perfectly reasonable for it to know. Like, that's kind of orthogonal to the idea of it being a forward iterator. Now, it's totally unreasonable for an input iterator to be like distance, like, because all input iterators that are iterating over the same object are all at the same spot, right? So there is no notion of differences between input iterators. And the same for output iterators, like for that category as well. The output iterator, you can't read the value, you can just set the value. And as soon as you set the value and move forward, well, the value is set, that's that. And you can never go back. And it's basically like you're tossing values into the void, right? One after the other. And all the output iterators, that's all you can do with them. Since you can't read, it doesn't, the notion of going backward to read something from before, that's a null concept. That you can't, since you can't read, there's no reason to ever go back. And there's no like, oh, I want to go and pretend that I output something else. No, you output it, it's gone now. So output iterators, also no notion of distance. No reasonable notion of distance. All output iterators that are iterating over the same object all point at the same place. They all point at the next thing that's going to be output. The next spot where things are going to be output. So that makes no sense either. But for all the other iterator types, it's perfectly reasonable to ask a question about distance. And it's also perfectly reasonable for that iterator type to have no idea. Like a doubly linked list is a bidirectional iterator. You can go back through the list, you can go forward through the list, but there's no easy way without advancing one by one to know how far forward this iterator is. You have these two iterators, you know that if you move this one forward, you're eventually going to meet that one, but you don't know how many times, there's no way to know without actually moving it forward how many spots you would have to move it forward by to know. So like doubly linked list is a good example, and singly linked list would be for forward iterator, right? Wouldn't know how far forward you'd have to go either. But it's also perfectly reasonable for it to know. There's a double-ended queue that has bidirectional iterators, and it actually has a really good idea of exactly where in the whole doubly ended queue each one is, and what the difference is between them. You could, in fact, compute a difference there cheaply. And in my case, like these forward iterators that I have, yes, I know exactly where in the whole stream of characters the forward iterator is. It's perfectly reasonable to compute a distance. In my opinion, the standard library distance thing shouldn't be checking strictly for the iterator category. Like I could check for the input iterator tag and the output iterator tag and go, oh, I can't do anything there. Like this is not a kind of iterator you can do a distance on, right? And then just refuse to answer the question at all. Like, it refuses to compile even if you try to call difference on two input iterators. But if you try to call distance on, like a forward iterator, it should go and look. Does this forward iterator know how to compute a distance cheaply? And if it does, it should use that. And if it doesn't, then it can advance the one iterator until it hits the other iterator, and let's hope for the best kind of thing, right? That's what should happen. And yeah, it doesn't do that. All the implementations in the trunk versions of these compilers, they all just don't do that. What happens here? Let's try. And then here we go this. Okay. Now, of course, we know what it does for standard distance. So let's do something here. Oh, iterT does have a difference type. Well, that's very interesting. I did not realize that iStream iterators had a distance type. Or a difference type. Let's actually define Fed2 here as it actually tries. It tries, and there is in fact no rational definition for distance for iStream iterators. Like, this code should fail to compile, but it doesn't, and I have no idea why it doesn't fail to compile. I guess one definition of distance would be, well, one of these is the end, and the other one is where you are, so then you find the difference, the distance is how many characters do you have to read to get to the end. But, yeah. This is so annoying that distance actually works this way. Anyway, I'm not going to try and make distance actually work in a way that's at all optimal. Um, this should result, in fact, in distance working in an optimal way. It should notice that there's an operator minus and use it. Sadly, it does not. Yeah, sadly, it does not. Oh well. And we're going to run our test because we made some changes. Now, ideally, we should have had some failing tests for the changes that we made, but yeah. Okay, so the tests work. I wonder what happens if I change this. So we already know right? I already know what happens there. It does something annoying. And here we're just going to comment out these. Right? Comment out those. And then we'll get our all big long definition of Fred. What happens if I just go here with Fred and go, hey, I'm actually random access iterator tag. If you say that it's a random access iterator, it does the right thing. I'm sorry, but that's bad behavior. I'm not going to do that because my thing is not a random access iterator, and I shouldn't be telling things that it is. Especially because it will totally, like, there's a couple of things that random access iterators should have. Is they should also have operator plus and operator minus defined to add or subtract an integer as well from your iterator, so that you can move your iterator forward by 5 or backward by 5 really easily. And I think there's a couple of other operations they're supposed to have other than that. But very definitely, you're supposed to be able to like move them forward by n by just adding n, whatever number n happens to be, to your iterator, or subtracting n, whatever n happens to be from your iterator. You're supposed to be able to move forward random access iterators forward and back by an arbitrary amount cheaply. And so they're supposed to also define operator plus and operator minus. And that I just don't want to do here. I could technically declare them, but one operator plus for an iterator that's pointing at somewhere that's far beyond where the underlying input iterator is pointing, that's really complicated to implement. Like operator plus for a iterator that's behind, as long as you're not going too far forward, that's easy, right? And operator minus is easy for all of them. But operator plus, not so easy. And so, yeah, sirens again, just a bit. One of the annoying things about living near a fire station is that sirens are a fairly frequent occurrence, which is why I had the sound turned off briefly. Anyway, yeah, I'm disappointed in the C++ standard, and I think they should fix it. And I wonder how CTRE works. I'm betting CTRE does not use difference type, which means that CTRE is always going to have a whole ton of code and be really inefficient when dealing with my input to forward range adapter, which is kind of annoying. Anyway, part of this was a distraction. Now that I have my ring buffer view, like reformed the implementation of it and have excellent tests for it and all that stuff, what should I do with my expression class or my parser here? I'm not quite sure what I should do next with it. I mean, I have simple expressions. One of the things I could add is support for identifiers, other than just, oh, you have an identifier. Well, we're just going to pretend that it has a 0 in it, right? I should add some kind of support for identifiers, being able to assign to them, and maybe multiple expressions that get executed one after the other. I should probably try doing that too. That's interesting. You can go back to the one that it implements, but in that case, it will just say equals 0 because it's all pure virtuals in the base class. Could do that. Another thing to add to it is maybe make it into a simple programming language where you have if statements or something. Maybe implement some kind of looping. Everything's an integer, but you can still do some looping. I don't know what to do with it next. Maybe I could add more operators. Maybe I could add exponentiation or something. I don't know. Not sure what to do with this parser next. I would like to make it slightly more complicated and have more levels to it. Partly just to flesh out in fuller detail exactly how to build a recursive descent parser, because this recursive descent parser with the levels that it has is just not it's not really complicated enough to give some good examples of what to do. So anyway, I think that that will be enough for today because I don't know where to go next. I spent most of today frustratedly fighting to see whether I could get the distance calculation for my iterator to be efficient, and it turns out that I cannot. And so then the next step is complexifying this lexer, and I'm not quite sure what the next step to take with that is. I'm open to suggestions. So because I don't know what to do, where to go with this next, I'm going to end for today. I should be back maybe Saturday afternoon, Pacific Daylight Time. Or maybe I'll be back certainly by Monday late afternoon, early evening Pacific Daylight Time. And maybe I'll decide to stop working on the lexer or the parser for now. Maybe that's what I'll decide. Anyway, one thing about this, I have pushed this to GitHub, and so it's my GitHub is omnifarious, right? So if we do, yes, I am using no. There, and so the URL is actually not this. It's that would be the URL. I'll paste it. Well, not paste it. I'll just put it in chat too, if anybody is curious. And if anybody has any suggestions, as I said, I'm open. But goodbye for this evening. I hope that you all have an excellent day.